Let's go over how to integrate these familiar functions with linear inputs. You should know how to integrate x cubed, but what about 2x minus 4 cubed? You should know how to integrate e to the x, but what about e to the 1/2 x minus 3? As it turns out, these are all pretty straightforward and don't require any additional special techniques. Let's try integrating a familiar function with a linear input the way we normally would if it didn't have anything inside of it. Then we'll check our answer and see what we have to do to correct it, and then we'll understand the general method for this type of problem. So suppose we want to integrate cosine of 5x plus 1. You should know that the integral of cosine is simply sine. But how is this linear function inside of cosine going to change that? Well, let's suppose it doesn't change anything. Perhaps we think the integral is just sine of 5x plus 1, plus the arbitrary constant. We could check our answer by taking the derivative of this, and we should get cosine of 5x plus 1 back. If we take the derivative of this, well, the derivative of the constant is 0, and then the derivative of sine of 5x plus 1 would be cosine of 5x plus 1. But then by the chain rule, we'd also have to multiply by the derivative of that inside function, 5x plus 1. The derivative of 5x plus 1 is 5, so we would multiply by 5. So we see our answer is not correct, because this has a factor of 5, whereas this, in the integrand, does not. But then it's easy to see what we need to do to correct this answer. If we had included a factor of 1/5 in front of the sine function, then when the chain rule gave us this factor of 5, it would cancel out with that 1/5, and we'd see that our answer is correct. So if we tried to take the derivative of this, we would get the 1/5 is still outside, multiplied by the derivative of sine is cosine, so cosine of 5x plus 1. The derivative of the constant is 0. By the chain rule, we got to multiply by the derivative of 5x plus 1, which of course is 5. The 5 and the 1/5 cancel out just as desired, and we see that this is correct. So in general, when integrating familiar functions with linear inputs, all we have to do is integrate as usual, then divide by the slope of the linear input. Just like we did here. We integrated the cosine, and then we divided by 5, the slope of that linear input. In more mathematical notation, if the integral of f of x is big F of x plus c, then the integral of f of ax plus b is big F of ax plus b times 1 over a. Just divide by that slope of a. And of course, don't forget your arbitrary constant. All right, let's go through those examples I showed you at the beginning. Let's begin with the integral of 2x minus 4 cubed. You should know how to integrate x cubed. We just have to increase the power by 1 and then divide by the new power of 4. So we'll do the same thing here, but then once we're done, we'll just have to divide by the slope of the linear input, which is 2. So we're going to have 2x minus 4, and we're raising the power by 1. So instead of a power of 3, we now have a power of 4, and then divide by the new power, which is the same as multiplying by 1/4. So that's just applying the reverse power rule, but then it's not just x cubed, it's 2x minus 4 cubed. So to finish this, we need to divide by the slope of that linear input. We'll divide by 2, so we would have divided by 2 over here, 1/4 divided by 2, let's just simplify that to 1/8. And there is our integral. Next, we have the integral of the square root of negative 4x plus 1. To begin, let's just rewrite this as the integral of negative 4x plus 1 to the power of 1/2. Square root is the same as a power of 1/2, and now we'll be able to integrate this, just like the first example, using the reverse power rule. We're going to increase the power by 1. 1/2 plus 1 is 3/2. So we have negative 4x plus 1 to the power of 3/2. Then we need to divide by the new power of 3 over 2. Dividing by 3 over 2 is the same as multiplying by 2 over 3. But because the input isn't just x, it's a linear function, negative 4x plus 1, we need to divide by the slope of that linear input. We need to divide by negative 4. So that's the same as multiplying by 1 over negative 4. Now, don't forget the arbitrary constant, and we will just simplify. 1 over negative 4 times 2 over 3 is negative 2 over 12, which we can reduce to negative 1 over 6. And then, of course, we still have negative 4x plus 1 to the power of 3 halves and our arbitrary constant. So that is the integral. Next, we have an exponential function. We're taking the integral of e to the 1/2 x minus 3. Now, the integral of just e to the x is e to the x, so we'll treat it like that at first. It's just e to the 1/2 x minus 3. Don't change anything. But the input is not just x, it's 1/2 x minus 3. It's a linear function. So we need to divide by the slope. Dividing by 1/2 is the same as multiplying by 2. So we'll throw a 2 in front, add the arbitrary constant, and that's the integral. In the last example, we are integrating secant squared of 5 minus x. What trig function has a derivative of secant squared? Hopefully you recall it's the tangent function. So this will be tangent of 5 minus x. But the input here is a linear function, so we need to divide by the slope, which is negative 1. Dividing by negative 1 is the same as multiplying by negative 1, and so that's our integral, making sure we remember the arbitrary constant. So that's how to integrate familiar functions with linear inputs. Just integrate them as usual, but then divide by the slope of the linear input. Let me know in the comments if you have any questions, and be sure to check out my Calculus 1 course and Calculus 1 exercises playlists in the description for more. If you find my videos helpful, please consider supporting what I do by joining Wrath of Math as a channel member. You can get early and exclusive access to additional videos, practice, and the lecture notes if you join at the premium tier or above. Thanks for watching.
Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about. Stressed out, honey, I've been stressed out lately. Don't know what's what, don't know what I'm stressed about. Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me